So I'm Kostas. I founded Data Artisans about 2 years ago. Started working on Apache Flink and stream processing way before that, so about 2010. So what do we do? So Data Artisans is a company that really started from an open source community, the community of Apache Flink. Apache Flink is a project of the Apache Software Foundation. By now, it has a global community of over 200 contributors. There are more than 30, 40 meetups, user groups all around the world, including one in New York City, which is holding a meetup tomorrow. And we are also providing the DA platform, which is the first commercial distribution, supported distribution of Apache Flink, which was actually launched last week. So I want to talk to you a bit today about what we call data streaming. So we are now witnessing a re-architecture of the data infrastructure stack. We see that sort of every couple of decades. And it's all about streaming technology. So streaming technology has many benefits, both from a business perspective and from a tech perspective. But really, if you dig down into it, it's basically a very obvious thing. So most data sets in most companies, most of big data, is data that is generated continuously. Yeah, so the real world never stops. Users, click all the time on your website. They order things all the time. Transactions happen continuously. Everything happens continuously. The fact that we have been basically putting this data at rest for a while and trying to make this while smaller and smaller before doing something with it is completely artificial, and it's basically driven by limitations of previous technology rather than use cases. Yeah? So streaming technology is basically enabling the obvious, continuous processing, continuous analytics on your data that is continuously generated. And this is, so let's geek out a little bit. This is basically how the stack looks like. So this is basically an architecture that every company is putting in place now. There's a variety of data sources. All of this data enters some kind of storage mechanism. Apache Kafka is something that is very, very popular. And what is cool about Kafka and other similar technologies is that it is structured as a log. So instead of knowing what's the state of my business right now, what you actually know is what is the history of events in my business. Next to Kafka, you have a stream processor, something like Flink, which is basically the new compute layer. And that is also the layer where you keep application state. So that is where several applications ingest the log and create the subset of the world that they are interested in. And then on top of that, you have all your usual, endpoints for this data, for the pre-processed data, databases, dashboards, search indexes, et cetera, et cetera. And actually, what's pretty cool about this is that if you look at this and you know how database systems are architected internally, this actually looks like a database that you have unboxed. So if we take a database and we reveal the covers, that's basically what it is. There's a commit log, there's data structures that are efficient, this is the application state, but can be recomputed entirely from the commit log. These data structures are snapshotted, this is basically what Flink does, and then there's a query layer that queries the database. So it's basically a re-architecture of the stack. The benefit now is that application developers can use these APIs directly, so they can actually build microservices that use these APIs instead of having all the applications go towards a monolithic database. And when we talk about data streaming, so lots of people associate data streaming with very fast, real time. Yeah, this is definitely part of streaming. However, streaming is really about continuous processing. So there's low latency streaming, and there's also high latency streaming. Yeah. And when we talk about bots, which is Hadoop and all of these technologies that we were used to, this is basically taking a slice of the stream. So batch processing is really stream processing, where the stream just happens to have a beginning and an end. So even better terms would be unbounded data processing, which is stream processing, or bounded data processing. So we see companies that are adopting streaming technology, and Flink in particular, that are coming from very different places. Yeah. So lots of companies, they want to be able to monitor their business in real time. Yeah, they want to know what their users, what their customers are doing right now, and be able to analyze this data and maybe react to this data. So this is definitely one adoption pattern for data streaming, real time. Another adoption pattern is all of these applications that people had put in place that are running 24/7, they're continuous applications, but maybe they were just implemented as standalone Java applications that were not fault tolerant. Maybe they were implemented by issuing Hadoop jobs repeatedly, one after the other, or in any kind of various ways. So another adoption pattern for streaming is how can we implement these applications robustly in a fault-tolerant way so that we ease the DevOps pain. Another big driver is microservices. So lots of companies are re-architecting both the stack and their organization around microservices. And if you look at microservices and what does that mean for the data layer, streaming is basically the obvious architecture, because there every microservice can build up its own local state instead of having a big database that all microservices have to query. And finally, another driver is unify what we call real-time data processing and historical data processing. And these are some of the things that folks are doing now with streaming. So Apache Flink has an annual conference. We had the second edition of this conference 2 weeks ago in Berlin. These are some of the companies that presented there. These are some of the companies that are using Flink, either in production or they're exploring Flink at good scale. So e-commerce folks, they want to get better product recommendations. So in particular, Alibaba, they saw that if you take into account the real-time information, then the recommendations can actually be much better. In finance, which is obviously a big thing here, so finance has been actually using stream processing for many, many years. And right now, lots of finance companies, they're trying to differentiate via tech. And they are adopting a lot of these technologies. For example, to provide push-based products, right? So imagine that you fly to a different country, like I did yesterday. You would very much like to get a notification that, hey, your card is unlocked, and this is the closest ATMs, or actually, hey, you need to unlock your card. In the infrastructure space, so telcos, machinery, IoT, so infrastructure monitoring in real time is a huge thing. So monitoring, towers, routers, factories, and being able to create alerts in real time. And of course, early adopters of these technologies, internet and mobile companies. For example, King is a big mobile game provider. They make Candy Crush and a bunch of other games. So they're actually ingesting all of this data that is really lots of billions of events, and in real time, their data scientists are trying to answer questions like, is this level too hard? Or what is the best place to place an in-app purchase, right? Things like that. And another thing that came out of this conference was the level of maturity of these applications, right? So this was only the second conference on the technology, but what we saw was that folks are actually building some applications that are pretty important to the business. So I mentioned Alibaba producing product recommendations for Taobao. That's actually an application that is running on a cluster of 1,000 nodes continuously, 24/7. King, the mobile gaming company, so these applications are actually maintaining state, yeah, and they are maintaining state consistently, meaning that if there's a failure, then the system always produces the right results, and that's hundreds of gigabytes of state, and others. So basically, the main thing that Flink brought in this ecosystem is the elimination of some hard trade-offs. So if you're into the space, I came to New York for Strata, which is happening right now. You know that there were also earlier technologies there, and people had been using things like Apache Storm, SAMSA, etc. The main difference is that the users of these technologies had to make very hard choices between what is the volume of the streams that can be handled efficiently, what is the latency of the application, and what is the accuracy. So basically what Flink brought is that this trade-off, you don't have to think around these trade-offs anymore. You can basically ingest and analyze streams of very high volume. So we have clocked it at tens of millions of events per second for stateful applications in actually very small clusters, 10 nodes, and you can also scale to 1,000 nodes. Latency is about sub-second, and you can get accurate computation results, meaning that if you have a failure or if the data in your input stream does not arrive in the right order, then the framework can handle it. So basically, what I want to leave you with is we're seeing, so this technology is maturing very, very fast. Flink is just a part of this ecosystem. And what we see right now is that having a framework that you can depend on, that is not going to fail you on high volumes, on fault tolerance, etc., actually makes companies move a lot more applications to this streaming architecture. So that's it actually for me. It's 3 minutes left. So there are lots of improvements coming to Flink. Right now, Flink is deployed in basically some of the largest infrastructures in the world. Lots of development of Flink is actually driven from there, make it operational there. And we as data artisans, we are continuing to basically contribute most of our code to Flink, and at the same time, we're developing the DA platform, which is essentially a turnkey solution to do stream processing, especially for companies that don't have the know-how internally to do all that stuff. If you want to learn more, there's a book that I wrote together with Ellen Friedman. It just came out. It's free. And it is provided by MapR. So if you Google for MapR, Introduction to Apache Flink, you can download it. It's not very technical, so it's intended to be both for a technical audience and a non-technical audience.
Do you want to join me here? So just a couple of questions from me, and then I'll open up to people. We should have a couple of mics somewhere. So great, thank you very much for being here. Can you give us maybe some stats on Flink, the community, how it's growing, like any data?
Yeah, sure. So as I said, so the Apache Software Foundation, we sort of measure how many people have contributed at least one line of code at the repository. That's a bit more than 200 right now. We see every release of Flink to have between 50 and 100 contributors. That's all around the world, so US, Europe, Asia. That is growing actually very fast now because very big companies are starting to use it. And the good thing is that these teams are becoming part of the community. So Alibaba, for example, has a very large team that is becoming part of the community, etc. So that's growing very fast. We saw last year a 2x increase. And that's going to be pretty much the same or more this year.
Yep, and it's always interesting for people, building companies. So this is a company that's built on top of an open source community. Any lesson learned in terms of building a community, fostering a community? I know you guys, so a bunch of you are core contributors to Flink, and then you organize a conference. Maybe tell us about how you foster the community.
Yeah, so our thesis is that if we're going to succeed if Flink succeeds. So we're all about contributing to the open source community. That is the core. And we have seen that there's sort of two types of users. Sometimes we joke and we say there's the West Coast type and the East Coast type. And we see there are folks that want to deploy this kind of technology, but want a bit more than Flink. They don't have the whole infrastructure to integrate to, which is the problem, which is the West Coast problem, but they actually need the infrastructure around that. And that is something that as a company, we want to provide, sort of a turnkey solution.
Okay, great. Can you help us contrast Flink versus Spark? What one is good at, what the other one is good at or not so good at?
Yeah, so the way I like to think about it is the following, right? So if your data is changing faster than your code, then you have a streaming problem. You have an application that's running 24/7 and is continuously ingesting data. If your code is changing faster than your data, then you sort of have a data science interactive exploration problem. And these are two very different things. So Flink is very much positioned to the first category. So your data is changing faster than your application is developing. Now you can do both with both Spark and Flink, but they have their strengths and weaknesses. So Flink is very much positioned in the streaming realm. So when you have continuous data, it does make a lot of sense, and there are lots of benefits to use a framework that embraces this continuous nature of data at its core.
Okay, great. Do we have questions? Okay. If not, tell us about, I'll use your opportunity to ask all the questions I want, that's great. Tell us about, I guess, the business model. So this, for each open source project, there are companies doing different things, services, other are hosting the cloud version of the software. How do you guys think about that?
Right, so as I said, we launched the DA platform actually last week. So we're just starting with that. Our business model is basically that the core is always open, and then software around the core that is needed, deployed in some infrastructure is licensed. Right now, the DA platform is just a Flink distribution, so it does not contain any other functionality, but it will evolve in the future towards a more complete platform that gives you a lot more. Okay,
very good. All right. Well, actually, we right on time, so this is perfect. Thank you very much. So you'll be.